Okay, this is lesson 14, section D. We're going to talk about ratios. Ratios is a way of comparing numbers, and basically it is a fraction that got tipped over to the left. So ratios are fractions that tipped over. They use ... called a colon to separate the numbers instead of a fraction line. To separate the numbers instead of a number line. Okay, and we're going to show you the exact thing of what it's talking about. So, write that down. I'll give you a moment. All right, so we're going to see a fraction. This fraction, 67 out of 100, how did they tip it over? Well, they tipped the 67 to the left. You're going to notice, and that's how they wrote it. Okay, so they tipped it to the left, and now instead of that line, they wrote ... Okay, and what is the word we use to say? We use the word to. So instead of us saying 67 out of 100, we say 67 to 100. Okay, that's the difference. So the way we word it and the way we say it is a little different than fractions. Okay, so fractions are out of a number, whereas a ratio is to a number. Let's turn the page. Let's take a look. Turn your page. I'm going to show you how to write the ratios for these. So we're going to count the squares. So here I've got 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So it tells me I've got 17 shaded squares out of 100. So please stop. So we would write this fraction 17 out of 100. A percent would be 17%. Now we're going to write it as a ratio. The ratio is going to be 17 to 100. Okay, so the ... means the letter TO, the word to. So we say 17 to 100. Over here on number 2, I've got 67 out of 100 shaded. Okay, so we would say shaded out of 100. So then we would say this is now 67 to 100, and that's how they wrote it for us. So 67 to 100. How do I know that there's 100 squares there? We've been using the 10 by 10. So there's 10 going across and 10 going down. That's how I know 10 times 10 is 100 squares. Let's look at number 3. Number 3, they shaded 51 squares. As a fraction, 51 out of 100. And again, we say out of. We can convert that to a percentage, 51%. The ratio is 51, and we use to 100. So I would say 51 to 100. That's how we would say it in words. The next one only has 8 shaded squares. So I would say 8 to 100. That's how I would word that. So as a fraction, I would have 8 over 100. As a percentage, times by 100, I get 8%. Okay? So what have they done to the fraction? They kicked it over and made the 8 sit beside the 100. But the top number sits first. That's what you're going to notice. The top number is first for the ratio. Let's take a look at B. B does not give us any diagrams. They just give us words. So it says that 38% of all customers, and remember, 38% means 38 out of 100. Okay, so it says, what percent of customers request water? Well, we would take that and we would times it by 100, and we get our 38%. Well, what percent don't want it? Well, if you know how many do, how do you find out how many don't? Right. You take 100, subtract your 38, you're going to get your 62. So now we're going to say how many out of 100 want it and don't want it. So this is now saying the want to don't want. And that's what they're showing the numbers here for. 38 want it, they want the water, but the 62 don't. So that's how they've written the ratio of how many do, how many don't. If it counts up, if you were to add those two numbers, what would they add up to? 100. They would add up to the same thing as a percentage. They would add to 100. Okay, so both numbers add to your total. So both numbers add to make the total 100. All right, now it says Miguel's teacher asked the students how many had completed their science assignment early. 18 of the 29 finished early. So we would write our ratio as 18 to 29. Now, if I wanted to write the ratio as done and not done, I would find the not done is going to be found by taking your total, subtract the done. So I would take 29, subtract 18, gives me 11. That's how I find my number 11. Okay, so now it says write the ratio who did not complete early. Well, the not would be not and then total. Doesn't matter. That's for your notes to keep. Okay, that's done. Okay, thank you. Alrighty, now turn your page. It says using ratios to solve problems. So now we got basketball going on. It says the ratio of girls to boys practicing basketball in the gym is 3 to 4. So that means for every 3 girls, you're going to find 4 boys. So it's a girls to boys ratio. So it says if there's 16 people practicing, how many are actually going to be in each category? So we set up a cross multiply and divide. So we set up 2 fractions. Two, cross multiply, then divide. Cross multiply, then divide. Okay, so we're going to do this example. So 3 to 4 for girls and boys. So we're going to set girls on top of boys equals the girls on top of the fraction and boys on the bottom of the fraction. That's the way they've set it up. So step 1 is setting up your fractions. Okay, we've done that. So we've got 3 out of 4 boys and girls. So the girls are on top. Here's our girls and here's our boys. This is our total. Okay, so how many girls are practicing? We're going to cross multiply, then divide by 4. So you're going to go 3 times 16 divide 4. That's the rule. 3 times 16 divide 4. So really, you don't have to worry about step 2 and 3. You literally just do this, and that gives you your answer. So 3 divided by 16, times 16 divided by 4. So how big is that going to give you? 12. So that's going to give us an answer of 12. So that means there was 12 girls and then there was 16 boys. That's what it tells. Okay, that's how many were practicing in the gym. Okay, so you're taking your girls to boys ratio, and notice everybody on the fraction diagram. I need to have the girls either all on top or all on the bottom. You can't mix them up and put one on top and one on the bottom. That's not allowed. They have to either all be on top or all on the bottom. Okay, you cannot mix those up. You have to, it's kind of like matching. You're basically matching the way they're set up. Okay, so you match the setup. Okay, and that's our fractions. And I'm going to draw a big circle around it right here. We match the setup. Girls on top of boys equals girls on top of boys. And then we cross multiply and divide to find our unknown. So we're finding an unknown answer. Okay, we wanted to find it. We solved it. All right, let's jump into the next question. We're almost done. I just have to zoom out. It's not zooming out very well for me. Okay, letter B. It says, here is my squares and my circles. Let's count how many I have. So I've got 4 squares and I've got 7 circles. Okay, 4 squares, 7 circles. So it says the squares to circles ratio is 4.7. We say the dot is 2. So we say 4 squares to 7 circles. Now, what if it says the squares increase to 20? Well, we have to look at the way it's set up. So if I've got squares on the left, this is going to become our top number. The guy on the left is always the top number. The guy on the right is going to become the bottom number. That's how you set up your fraction. Okay? So now we're going to see how they set up the fraction. 4 on top, 7 on the bottom. Okay? And now we have to figure out, well, if they say, because I've got squares on top, circles on the bottom. Now we're going to cross multiply and divide. So I would take 7 times 20, divide 4. So 7 times 20, divide 4, we get 35. So that means there would be 35 circles if you had 20 squares. So we're getting our answer. The answer we have is 4 over 7 equals 20 over 35. So we found our missing number, which was on the bottom. Okay, that's what we found, the missing number. And again, we had it set up as squares, whoops, that's a diamond, squares to circles, squares to circles. So you always have to have them set up properly together. All right, now we're going to jump into letter E, proportions. Proportions are a fancy way of saying ratios again. All it is ratios and fractions, and we're solving for an unknown. So calculating proportions is all about, again, cross, multiply, and divide. Cross, multiply, then divide. That's what this all is about. So we need to set up 2 fractions. Okay? So we set up, it's glitching out here a bit. We set up 2 fractions. So again, that's why we had to do our fraction unit first. So that big fraction lesson, lesson 13. Okay, so it says ratios that are equivalent can be expressed as proportions. So it says they're used in a variety of ways, such as building homes, roads, model cars, shopping malls. Artists often use them for creating sculptures as well. So Miss Marsh knows very well how to use ratios. So it says, Pearl likes bird watching. Every Saturday, she looked for different species of birds. For several Saturdays, she noticed a ratio of 2 robins for every 3 sparrows. On another Saturday, she saw 18 robins. So how many sparrows should she expect to see? So we've got it set up as robins over sparrows equals robins over sparrows. So that's how our fraction is set up right here. And now we cross multiply and divide. So I'm going to multiply this way and divide by the number left over. So we're going to take 18 times 3, divide 2. And that's going to give me 27. That's my missing number. So if she saw 18 robins, she should expect to see around 27 sparrows. Okay? That's our missing number. Again, and what did we do for most of this? It's just cross, multiply, then divide. Okay? So now B says she's seeing hummingbirds. 4 for every 7. So again, we're going to set it up. Hummingbirds to bluebirds. H over B. And over here, we've got hummingbirds. We don't know. Over bluebirds. So again, we're going to cross multiply, then divide. So you always multiply the numbers that are diagonal. So think diagonal disco. Yeah, baby, disco. Okay? Disco those numbers. All you're doing is multiplying. Disco multiply, okay? It's kind of fun. Woo! Okay. So we're going to get n is 16 after you cross multiply. So we're going to get 4 times 28 divided by 7. Miss Walker, we instituted a new rule in the room. So to borrow a calculator, they need to put their phone on the wall in a spot on the wall there. So that's why their phones are on the wall, because they borrowed a calculator. And then we'll for sure get them back. Okay, that's the end of that. Let's take a look at letter C. Turn your page. We're almost done, guys. Turn your page. I do. So when we see objects like this, it says we have picture frames. We have one that's a 10 by 12 and one that's a 24 by 20. It says, are they proportional? Well, we want to see if we get the same answer. So what I would do is I would take large side over small side, and I'm going to divide them, and I'm going to equal a decimal. And I'm looking to see, do my decimals match? So this question is saying, hey, here's two objects. Are they proportional? If they're proportional, that means if you divide them, you get the same decimal. So that's what we have to figure out. So to compare, see if their decimals match. If the decimals match. Okay, so we're seeing if these decimals match. So if I take large divide small, 12 divide 10, if I divide them, I'm going to get 1.2. Now I need to do the same thing on the big one. So I need to take my large side, divide small side. So I'm going to take 24, divide 20. And I want to see if I get the matching decimal. And guess what? Boom. I get the matching decimal. So here we go. 1.2 matches 1.2. So I say yes. My answer is yes. They are proportional. The decimals match. Okay, yes, the decimals match. That's why we had to take all of our units and all of our lessons where we did decimals. That's why we had to do the decimals part first. So yes, the decimals match. Okay? They did it by using common numbers, multiply them both by 2. Do you get the same answer? Yeah, you do sometimes. Okay. Then you can also see, do they reduce? So they took small over big, and then they reduced it in the calculator to see if you get the same answer. Small divide big. So they did small divide big, and they reduced. So on our calculators, how do we reduce? We hit our second, and then P and then equals. So second PRB equals. That tells us our lowest form of our fraction. So if we put in 10 divide 12, second PRB, we get 5 over 6. If I go 20 divide 24, second PRB, I get 5 over 6. So this is what we're trying to do, is we're trying to match our lowest form. So these guys match. Okay, those lowest forms, what I highlighted in blue, those match. A small set model company wants to develop a model kit of well-known cars, trucks, and airplanes. One of the specific cars has a length of 300, a height of 150. So we are going to write a ratio of, let's see, length and height. So height dot length is what they've got. So it says they want to compare to 30 centimeters. So if they make 30 centimeters in length, what would that be? So what we've done is we've done this. 150 over 300 equals x over 30. That's all we've done. And now we're going to cross multiply. And then divide by the number left over. If we divide by the number left over, we're going to get 15. So we get x equals 15. Okay? Well, that tells us, because this is set up as height to length. This is height. Length is on the bottom. So we found a number that is the height. So we found 15 centimeters would be the height. Okay, so again, it's a cross multiply and divide situation. Turn your page. Okay, Sylviana has coins in the ratio 1 loonie to 3 nickels. So she's got a 1 to 3. So it says 1 loonie to 3 nickels, and it says she has 60 cents in nickels. Well, if she has 60 cents in nickels, we have to divide that by 5. So we're taking 60, dividing by 5 cents. So 60 cents divided by 5 cents gives us 12. So that means she's got 12 nickels. Okay, that's what that tells us. Then we got to set up loonies. So we want loonie to nickel. So that means as a fraction, we're going to have loonie over nickel. So she says she's got 1 loonie, 3 nickels. We just found out she has 12 nickels because she has 60 cents. Well, then how many loonies would she have up here? That's our unknown. So again, this is a cross multiply and divide, folks. So we're going to multiply and divide by the number left over. So that means she would have 4 loonies. So x equals 4, and it's a top number, which means 4 loonies, which means $4. So how much money does she actually have in her pocket? If she's got 4 loonies and 60 cents, how much does that make altogether? How much is 4 loonies? $8. How much is 4 loonies? Loonie. $4. I want to add 60 cents. How much would I have? $4.60. Absolutely. So she has, we're going to write it as money, $4.60. That's what she has in her pocket. That's what we found out. Okay? This concludes section D and E of lesson 14.